It's day 5 of Advent of Cyber, which means we have a new activity, a new challenge, and something new to go over. So without further ado, let's get started with the video. But before we even do that, go ahead and do me a favor. Hit that subscribe button, hit that like button if you enjoyed today's video and you would like to see more challenges for Advent of Cyber. Alright, let's get into the video. Alright, so today's challenge is Socmas XX What EE. So the days in Wareville flew by and Software's project were nearly complete. Just in time for Christmas, one evening after wrapping up work, Software was strolling through the town when he came across a young boy looking dejected. Curious, Software asked, "What would you like for Christmas?" The boy replied with a sigh, "I wish for a teddy bear, but I know that my family can't afford one." This brief conversation sparked an idea in Software's mind. What if there's a platform where everyone in town could share their Christmas wishes and the mayor's office could help make them come true? Excited by the potential, Software introduced the idea to Mayor Ware, who embraced it immediately. The mayor encouraged the team to build the platform for the people of Wareville. Through the developers' dedication and effort, the platform was soon ready and became an instant hit. The townspeople loved it. However, in their rush to meet the holiday deadline, the team had overlooked some critical, thorough security testing. Even Mayor Ware had chipped in to help develop a feature in the final hours. Now it's up to you to ensure the application is secure and free of vulnerabilities. Can you guarantee the platform runs safely for the people of Wareville? So we have a few learning objectives today. So the first one, we want to understand the basic concepts related to XML. Then we're going to explore XML external entity, being XXE, and its components. We will learn how to exploit the vulnerability, and then we will understand the remediation measures. So we have a few important concepts. We have extensive markup language, also seen as XML. So basically, XML is a commonly used method to transport and store data in a structured form. So this allows computers to be able to share data, just to kind of understand and explain and share information. So this agreement format is known as XML. And just like a file cabinet where there's documents, labels, files, and folders, XML uses tags to help organize this information in a similar format. So if you see here, we have a case where the tags will be people, name, address, email, phone, and these folders are like the files in the cabinet where the context inside the tags are glitch, Wareville, the email address associated with the email, and the phone number. So this would be the actual data that is being stored within the folder. So now that we have agreed on a common format, now we need something to be able to structure that data. That will be something that we call document type definition, or you see it as DTD. This is basically your blueprint to tell the elements and attributes exactly what you want to allow and not allow within your XML file. And it also gives your file a specific structure. So let's take a look at this example just to kind of understand what's going on. So you have your doc type, which is also going to be how you would determine the DTD. So we have the doc type being, or the document about people, and this will also include name, address, email, and phone. And then we have data with inside that element or tag that would be PC data. This is where you're going to actually enter plain text, so this will be easily readable to a human. So you have your name, and within that name, you'll have the data for that name, you'll have the data for your address, email, and so forth. Within that, now we have agreed on a structure, we've agreed on a format. Now we need to understand the type of data that will be shared. This is what we call entities in XML. Entities will be placeholders that allow you to insert large amount of information, referencing whether it be internal or external files, to allow you to easily manage and repeat multiple times. So for this example, they give us an external entity reference where we can see we are using this particular syntax, ext for internal, to locate a external file, which will be hosted on this website with the robots.txt. As we can see in the example, we also have the same exact thing. We're referencing our entity. We want to reference the external entity, and then this will be the actual external file we want to locate. However, with these external entities, this is one of the reasons we fall victim to these particular vulnerabilities, because if the external entity is not managed properly, it would allow anybody to really enter anything they want for that external entity, allowing it to potentially navigate to the wrong site or a malicious site. So now we go into XML external entities, also seen as XXE. And basically the XXE vulnerability is an attack that takes advantage of how XML parsers handle external entities. So when a web application calls an XML file that contains an external entity, that parser then attempts to load or execute whatever is within that external entity. So if there are not the correct parameters or sanitation in place to say, hey, we only want to allow this particular entity, or we only want this entity to point to this specific thing, it could allow for the vulnerability to be exploited by having malicious code within that external entity. So as we can see from this example, we have the external entity as THM file, and then this is the actual file we want to reference, being file.etc at password. If you don't know what that actual directory is, within the Linux box, this will tell you all the users and their password within that device, which can allow for those username and passwords to be compromised. And that's not something that we want. So now that we have learned about all these different concepts that we need, let's go ahead and start our attack box and get on with the challenge. So we have already started our machine ahead of time just to save some time with the loading. So let's go ahead and visit our application hosted on http 10.10.131.28. So we're going to go ahead and copy this. All right, and we'll go ahead and paste our IP address. And let's see what it wants us to do. So first we want to look over the flow of our application. So as a penetration tester, it's important to analyze the flow of the application first, just to kind of get a gist of what the application does. So we want to browse through the products and add items to our interest to their wish list. We can go there by visiting product.php, then click on wish list, and under where there's Jolly Cap as shown below, we want to add that. So let's go ahead and do that. So we want to go to products, which takes us to product.php, and then we want to open up the where there's Jolly Cap. We want to add this to the wish list, and then we want to go to cart. We want to proceed the checkout, and we could just name a full name. And we'll do and we'll click complete. And now we can see that our wish has been saved at wish 22. So let's go ahead and click on that. And we get an error. So Santa's elves are the only ones who can read this wish. Okay, so now we know a little bit about the information, we know a little about the website, we know what we can access, what we can't access. So let's take a look at what we have to do with the challenge. So before we get into the actual exploit of the vulnerability, we want to be able to intercept their request. So we're going to open up Burp Suite. Let's go ahead and minimize this. And we'll click next and we'll do start burp. All right, so we can go ahead and click the X. And as you can see, our three main categories we're going to be working in today will be proxy, intruder, and repeater. But before we do that, let's go ahead and go into our settings. We're going to do Burp's browser, and we're just going to check this to allow Burp's browser to run without a sandbox. And we'll click out. And now let's do some intercepting of the actual website. So we'll go to proxy, make sure intercept is on, and then we're open browser. I believe in the actual example, they want us to have intercept off and kind of do it through the HTTP history tab. But just for video purposes, I'm going to do it through the repeater, so we're actually able to see each request when we do the get command or the get request. So we're able to see it and not have to go through the history to then send it to the repeater. All right, so let's go ahead and do open browser. And we will paste our URL that we want to visit in here, click enter, and we can see from this red dot, we have some traffic going on within our proxy. Before we forward it, because we want to send it to the repeater, we will do Control R, and so you can see it lit it up. It highlighted, which means it's sent to the repeater. And then we want to go ahead and do forward the request so that we're able to visit it. And now we want to go back to products. We're going to do Control R to send it to a repeater, then forward it. And we will go to Where There's Jolly Cat, Control R to send it to the repeater, and then forward it. We will add to wish list, and we're going to send it to the repeater and forward it. Then we want to go to the cart, send to receiver, and forward it. We'll do proceed to checkout, forward it. And now we want to enter our checkout information, and we'll do the same thing. Hit complete checkout, go back to Burp Suite. We're going to send it to our repeater, hit forward, and then we want to get to this wish. So now we have wish number 22. Go to Burp Suite. We're going to send that to the receiver, and we'll hit forward. So this is what we want to kind of pay attention to, the context of this particular site, because we know that someone can access this, but only the elves have permission to it. We want to see if this vulnerability does exist on the website, and then once we see if it does exist, then we want to go ahead and exploit it. Let's go to our repeater, and we can see we have all our requests here. So let's see. All right, so this is our post request for the wishlist.php. Let's go back to our challenge, and we can see right here when we did the post request, we got some XML as an input, and we can see that our request was the wishlist.php, and we have wishlist user ID. In this case, our product was number 1, user ID, item, product ID, item, and wishlist. So now we want to see if this vulnerability actually exists. So we're going to prepare the payload by just copying this. We see that we're going to be using the XML version, and then we are going to be replacing the ID with the @ symbol, or that may be, I don't even know what's the correct term for that, but I call it the and symbol, and payload. So let's go ahead and copy this, and we will paste it into our request for the wishlist.php. We will replace it in replacement of this. Let's go ahead and paste that. Hit send. And we can see that this vulnerability does live on this host. Alright, so now that we know that this vulnerability is living on this site, now let's take some action on the actual website. Not all web applications use this pad, but most web servers use it. So let's go ahead and take it to our advantage. So instead of using the etc host, we're now going to change that to var www.html, since this is a web server. And then we're going to recall the page that only is accessible by admins. So let's go ahead and copy this, paste it here, and hit send. All right, so we can now see the product ID. We can see who this belongs to. We can see the address. We can see the product, and we can see the quantity of the actual product. So surprisingly, we got lucky with our assumption, where the next thing to do is to see whether we can view more wishes using our directory. To do this, let's try replacing wish_1.txt with wish_2.txt. All right, so we'll change this from 1 to 2. Remember, our txt was 22, so we can send it, which kind of tells us it at least has 22 different text files for this. So now we see a whole different wish number. We see this is belonging to malware. We see this address is a test. Looks like maybe he's doing some testing. And then we have a product of where it came with the quantity of 1. So let's just see our particular one just for the kicks of it. We'll do send. And we can see when I enter my actual information, this was my name, this was the address I used, and we can see the product. When we did our walkthrough of the website, we should see my name as well, which we got wish_21. So let's go ahead and try that just for the kicks to make sure we are on track. And as you can see my name again. You see the same address and you see the same product. So let's see what our next step is. So it was confirmed that the application was vulnerable and the developers were not at fault, since they only wanted to give the townspeople something before Christmas. However, it became evident that bypassing security testing led to an application that did not securely handle incoming requests. As soon as the vulnerability was discovered, McSkitty promptly coordinated with the developers to implement the necessary mitigations, and the following proactive approach helped to address the potential risks against XXE attacks. After discovering the vulnerability, McSkitty immediately remembered that a changelog file exists within the web application and stored at the following endpoint. Okay, so that's good to know for future reference. And then after checking, it can be seen that someone pushed the vulnerable code within the application after software's team. So with the discovery, McSkitty still couldn't confirm whether the mayor intentionally made the application vulnerable. However, the mayor had already become suspicious, and McSkitty began to formulate theories about his possible involvement. Okay, let's get to our questions. So what is the flag discovered after navigating the wishes? So we could change our number starting at 1 and just kind of go through it 1 through 21, or we can send this request to our intruder and have it run that way by number. So I think that's what we're going to do. I'm actually going to do Control-I, which will send this to the intruder, as you see that highlighted. So now we see the same exact request, and now because we want to reference our number, we're going to go ahead and highlight the number, click add, and now we want to adjust our payload. So we want to change the payload type from simple lists to numbers. This will allow us to kind of define which numbers we want to go through. So since we know we at least have, starting from 0, and we at least have 22 different numbers, let's go ahead and do from 0 to 22. We want the steps to be numbers, so this will go up by 1. So 0, 1, 2, 3, 4, 5, 6, 7, and so on. And that's really all we really care about. We are going to hit X, and we're going to do starter tag. And community edition. This is just telling us because we have the community edition, this contains a demo version of Intruder. We'll just click OK. And now we have all our payloads and requests. So we just gonna go through all of them and see what we find. And we'll change this to response to actually see what we're looking for. So what we want to keep an eye on is the product ID, the name, and the address. Let's go back. And we can see here, we have a flag. So the flag is, let's go ahead and copy this and paste it here. And then our next question is, what is the flag seen on the possible proof of sabotage? So as you can remember here, we actually got to see that we can view our changelog file that exists within the actual web application to basically see when someone pushed vulnerable code. So we'll just copy this web address. We'll minimize this, and we will visit it in our Firefox. All right, and we can see the fix the wishlist.php page with the actual flag associated with it. Let's go ahead and copy that, and that may be our answer. All right, so if you want to learn more about XXE injection attacks, you can visit TryHackMe's XXE room specifically for that. We'll just click complete. And following McSkitty's advice, software recently hardened the server. It used to have many unneeded open ports, but not anymore. Not that it matters in any way. So we will go ahead and complete this as well. And we are done with today's challenge. If you all found this video helpful or you enjoyed the video, go ahead and hit the like button, hit the subscribe button, and I will see y'all again tomorrow for day 6.
Keyboard mechanical, 100 a minute, I type and that's factual. So I'ma get back at you. Yeah, all of y'all talking about Christmas is magical, but I hope you're encrypted. But I don't even care if it's 256-bit, cause I'ma get past it. Y'all don't know yet I'm that shit. Better watch out, you better go high. I'm coming to town, you see what I type. No running away, cause I am the character you can't escape. Nobody gon' catch me. None of y'all ever gonna get past me, and no one gonna know what the patch be. Such a bad breach, I'm too nasty. Now I'm coming right for the magic. I hope it was fun while it lasted. Now Christmas is mine and the fact is you can't patch this. I'm a savage. And now they all call me a mean one, Mr. Grinch. Yeah, the heck I is.